We are going on now to think about volume. There's different ways to create volume. The illusion through perspective and scale. There's also ways through shading and directional line. So we're going to cover all these things, but first we're going to look at plan and elevation terminology so you understand the difference. You probably know this from maths, but we're going to cover these points anyway. A plan view is a view from above, looking down. Now this cube in plan is obviously square, the cylinder obviously a circle. So we're now going to consider where we would see that. We would see it on a map. Now you'll be more familiar with Google Earth. I have an old school A to Z of Manchester. I'm in Altrincham. I'm looking at Broadheath, and this particular building, this works. It may no longer be here. If you live in the area, you may know. But this is the shape of the building from above in plan. Now an elevation, you often hear elevation used in architectural terms, is a side view, a view from the ground looking at that front profile or a side profile. Now this book is quite old, it's an old architecture book I've had since I was a youngster, an old ex-library book. But Sydney Opera from the water is in elevation. Now if I go back to the cube, and just pop it in front of us, we have the plan looking down, we have the elevation from the side. Plan, elevation. So we've considered the terminology. We're now going to apply some of this in a simple exercise. This is a rough exercise, but I want you to try and do it as accurately as you can. Your drawings can be rough, but correct any errors. So we're going to consider plan, elevation and three-quarter views. There are various types of three-quarter views, such as oblique, isometric. We're going to follow some principles and I'm going to talk you through them just for the purposes of this task. So the cylinder, in plan, we know it to be circle. So in the plan box, we're going to doodle a circle. Look, it's a rough working out drawing. That's fine, searching for the line. So in side view, it is an elevation. We know it's a rectangle. Now from your viewpoint, you might see the distortion of the arc at the top of the bottom. But we're drawing the theory in here. Now, if this was a tin of beans, a standard tin of beans, it would be slightly taller in terms of its height-width ratio. If it was a toilet roll, it would probably be about this proportion. But this is the ratio roughly of this one we have in front of us. So you can modify these based upon the type of cylinder you're constructing. Now this bit is important. So as we tip it from a full circle, it starts to take an elliptical form at the top, all the way to the point when it becomes a straight line and we can see a horizontal line. So I want to suggest that it is a continuous line. It doesn't come to a point. Sometimes when people are drawing an oval from this viewpoint, they create what I call the fish, a kind of pointing end there. It's not, it's a continuous line, it's a smooth line. So try and avoid a point. In construction, you might start drawing one. So I'm drawing a shallow ellipse. See, I'm searching for the shape, I'm happy with that shape. Now, we are going to draw two vertical lines in to create the illusion of this rectangle at the side. But even though it sits flat on the table, this is an arc line. So follow the logic here. If we draw two parallel lines, look at them, both my fingers are running around the arc, you'll create an illusion. Now, if you know anything about this and you've observed this, it's not quite true. They're not quite parallel. But for the purposes of the exercise, we're going to make them parallel. So that arc parallel with this one. If you're not sure, draw over it. So you've got the action memory, like in sport, you've drawn, you've just echoed the same memory in your action. Now remember, it's not got the fish point, so we'll just soften that line. So there we have a fairly reasonable looking cylinder, illusion of a cylinder on a piece of paper. So the cone, in plan view from above, we know it's a circle. In elevation, it is a triangle. Now this is probably an isosceles triangle, maybe slightly more equilateral. You know what these things mean. If it was an ice cream cone, obviously its height-width ratio will be different. It will be narrower here and therefore steeper in the side. Obviously, you'd mostly look at an ice cream cone from this viewpoint, but you understand the principles. So, obviously, in its 3/4 view, we are going to draw the triangular shape. But this is not an elevation, it's a 3/4 view. We can see it's part of the top and part of the side. So we have an arc. I'm going to tip this up to draw the arc. You can see the arc. It becomes steeper the more I move it around, or shallower. Remember, no fish features. It is a continuous line. It is a circle. It is a continuous line. So I'm just going to soften that line there. That will do for my illusion. And it is an illusion because it's a drawing. Now the cube. In plan, it's a square. In elevation, it's a square. Now the principles of this can be applied to a cuboid. So we've got two squares. In 3/4 views, we can either see 3 planes, the top and the 2 sides, the plan and 2 elevations. We could turn it round so we can see the plan and a single elevation, and there is distortion on here, but for the purposes of what we're doing, I'm going to teach you an isometric drawing technique. So I'm going to draw 3 parallel lines. 3 parallel lines. And I'm going to construct these last 3 parallel lines. Now this is not in perspective, so if you know anything about perspective, this is not true, but it is creating the illusion of a cube. So that line, and that line are parallel, this one, and this one are parallel, and the verticals are all parallel. But it works for the purposes of what we're doing. And finally, the easiest or the hardest, we have a sphere. So in plan, we have a circle. In elevation, but in 3/4, we have exactly the same thing. So whilst on the other shapes, through the drawing in a 3-dimensional form, we can create volume. Without anything else, the circle will still look like a flat plane. So we need to move on to learn about other ways to create volume.